Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, step 2, step 3, and your challenge is to predict the number of dots in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of dots in any step at all? If you'd like to accept that challenge, pause the video and work it out. Okay, let's see what we've got going on here. It looks like we've got just one dot in step 1. Oh, and then we add a lot here in step 2. So it looks like this is getting big pretty quickly. What do you think? Is this linear? Is this quadratic? Do you have a sense of that just by looking? One thing that I notice is we have this single dot of 1, and that stays constant. So we've always got this 1 here. And then, let's see, it looks like a group of 10. So we add a group of 10, and then here we've got that group of 10, and we add another group of 10. So it looks like we take 1, we add 10, we add 10 more. So for step 4, I would think we just add 10 more. It seems like that's what we're doing each step. So that would be 10, 20, 31 all together. So my prediction for step 4 is 31 dots. If we look at the numbers in a chart, I'll make a chart with the step number and the number of dots here. In step 1, we've got 1. In step 2, that's 11. In step 3, that's 21. And in step 4, that's 31. And we can analyze these numbers by just finding the difference between each step. So 11 minus 1 is 10, 21 minus 11 is 10, and 31 minus 21 is also 10. So you can see we're getting a constant, the same number. That means this pattern is linear. When a pattern goes up by the same amount each step, it's a linear pattern. Even though this is growing rapidly because this number, this difference is 10, it's not anything beyond a linear. It's not a quadratic because it's growing by the same amount each time. And when it's a linear pattern, we can use this linear equation, the equation for a line, to model that. The difference here, the rate of change, is going to be our m. So we'll put that in for m. So y equals 10 times x, and x stands for the step number. And this plus b, we don't know yet. We have to try it out. And I'm going to try it out with step 1. So if I try out this stem of the equation, 10x, and in this case, since x is a step number, I'm going to put in 1. So 10 times 1. And y should give us the number of dots. So y equals 10 times 1. Well, that's 10, but there's only 1 dot here. So that is 9 too many that we have that our equation is predicting. So we can fix that by just subtracting 9. So now 10 times 1 is 10, minus 9 is 1. That's how many dots we have there. So our b is actually a negative 9. Let's test this new equation, y equals 10x minus 9, with step 2. So y equals 10 times step 2 minus 9. So that would be 20 minus 9, that's 11. That's how many are here. And in step 3, it would be 10 times 3 minus 9. That would be 30 minus 9, that's 21. That's how many there are in step 3. So our equation is y equals 10x minus 9. And now to get the number in step 43, we're just going to plug 43 in for x. So y equals 10 times 43 minus 9. So 10 times 43 is 430. So 430 minus 9 is 421. So I think there are 421 dots in step 43. Well, how did that go for you? Did you get 31 for step 4? Did you see that this was linear, or did you think it might be something else? I'd be interested to know. Thanks, everybody.